Hi, TayShaun. So this video is going to help you with lesson 6. So first, I'm just here in your course. I want to make sure that you see at the top of each lesson, there's lots of extra tutorial videos. If you go through the lesson and you still need help, come back up here and check out these videos. Sometimes that will just answer the question that you have. So just know that these are there inside of each lesson. Okay, so this lesson is exponential functions. And one thing I'd like to model for you in this video is how to take notes when you're doing your math course online. So I just have a piece of paper here, and probably be better if I had lined paper, but this is just what I had sitting here right now. So I would write lesson 6, and then anything I find important or examples, I'm going to write here. And you can always pop back into your course when you need to, like back into the lessons and look, but usually it's nice to have notes with the important things just right there. So hopefully you have like a spiral notebook or some loose leaf paper or something where you're taking notes as you go. Okay, so exponential functions. So when you go through these lessons, make sure you read all this. I know it's really tempting to just go straight to the numbers, but if you don't read this, this is like the stuff your teacher would say out loud if you were in a traditional classroom. Okay, so you probably remember the word exponential from previous lessons. When learning about geometric sequences, you saw how they display exponential growth over the domain of natural numbers. This means that the growth or the increase starts slow and then grows faster and faster. Exponential functions are similar, but the domain can be all real numbers. This means they can be continuous functions that go forever in both directions. Okay, so the change here is we're looking at all real numbers, and these can go in both directions forever and ever. So here's the graph of f of x equals 2 to the x power. So here's the graph. It can go forever in both directions. Obviously, that graph is just a piece of the picture there. From the graph, you can see the function f of x equals 2 to the x is a continuous function, and its domain is all real numbers. You've already worked with functions and equations that involve exponents like this. However, exponential functions have a variable as the exponent. So here you can see that x is the exponent, where here 2 was the exponent. So there's a difference here. This is called an exponential function when the variable is the exponent. Okay? And that's just what I said right here, that key concepts. Also, in an exponential function like this one, the base of the exponent, the number 2 in this case, is called the growth factor. Okay, so this is the first thing I'd like you to write down on your notes. Growth factor. So I'm going to use this example, f of x equals 2 to the x, and they just told you that the number 2 is the growth factor. So right here, I wrote growth factor. I'm pointing at 2. This is the growth factor. The base is the growth factor. So the growth factor in this example is 2. Okay, so the number 2 in this case is called the growth factor. This means the output for each function is multiplied by 2 to get the next output. So we'll see that here in a second. A growth factor is the factor that the output of the exponential function is multiplied by when the input value changes by 1 unit. The growth factor is the base of the exponential equation. All right, when a growth factor is greater than 1, it causes growth. Okay, I'm going to hop back to my notes. When this is greater than 1, so when growth factor is greater than 1, it causes growth. When a growth factor is between 0 and 1, it causes decay or decreasing values. So when it's between 0 and 1, so when a growth factor is between 0 and 1, it causes decay. Okay, you can pause the video anytime if you need to take time to write here. Okay, so consider the same function that we've been working with. As noted, the growth factor of the function is 2. Because 2 is greater than 1, you can expect this function to show growth. Examine the table of values. So let's see what happened over here. When I plugged in 2 as my exponent, I got 4. When I plugged in 3, I got 8. When I plugged in 4, I got 16. So you can see we are showing growth as we increase the x value. Growth rate is the rate at which a function changes or increases or decreases when the output value is changed by 1 unit, usually written as a percent or a decimal form of a percent. So 1 plus the growth rate equals the growth factor, or the growth factor minus 1 equals the growth rate. Okay, so growth rate is something new that they're about to tell you. So we have growth factor up here. Maybe I'll make like a little box to show that was the main thing. And now we have growth rate. And what it said about growth rate was the growth factor minus 1 equals the growth rate. So growth factor minus 1 equals the growth rate. So for the previous example, the inputs increase by 1 unit, the outputs increase at a rate of 100%. So because our growth rate, or our growth factor was 2, if I subtract 1, 2 minus 1 is 1, and they write it as a percent, 100%. So that's one example there. There's another way to think about this. When you write the growth factor of 2 as a percentage, it tells you the output is 200% of the input. Use this formula to find the growth rate. So this is just the other way around. The growth factor minus 1 equals the growth rate. So 200% minus 100% equals 100%. So you can do it either way. Let's look at a whole nother example with a different problem. Okay, so here's another example. Find the growth factor and growth rate of f of x equals 0.85 to the x. So I'm going to write this down. Example. F of x equals 0.85 to the x. So we need to find the growth factor and the growth rate. So growth factor is easy. You just look at which number is being raised to the exponent. So growth factor equals 0.85. Okay, growth rate. So growth rate we wrote right here is the growth factor minus 1. So we need to take 0.85 and subtract 1. So we're going to go 0.85 minus 1. So I get 0.15, negative 0.15. Okay, so let's go back here. And that's what they got to, negative 0.15. And we know it's negative because it's going to be decay. Remember where we wrote down that if the growth factor is between 0 and 1, it causes decay. And since this number is between 0 and 1, we know it's going to be decay. So the growth rate was negative 0.15, or you could write that as negative 15% if you want to write it as a percentage. All right. So we have exponential functions in terms of growth rate and growth factor. Okay. We basically went over all of that and already have that in our notes. Horizontal asymptote. All exponential functions have a horizontal asymptote. The horizontal asymptote is a horizontal line that a graph of a function approaches but never reaches. On the following graph, f of x equals 2 to the x, y equals 0 is the horizontal asymptote of the function. The function gets infinitely closer and closer to the horizontal asymptote but never actually touches the line. So this graph, it will get close and close and close here, but it's never going to dip below 0. Okay, that's called an asymptote. It's like a border. Where is it not going to cross? Okay, input out. Actually, maybe we should add that to our notes really quick. I'm just going to sketch that little graph and just show that this is getting really close to the y equals 0, but it's not actually touching it. So horizontal Let's make sure I spell this correctly. YMP. Horizontal asymptote. Okay, now we can go down to that next part. Input-output table. So before you can learn how to graph exponential functions, you need to know how to fill out an input-output table, sometimes called a T-chart. Make an input-output table for this function. F of x equals 1/4 to the x. Okay, so they did this for you. So we have our input, we have our output. We've done that already in the course, but now we're dealing with something tougher, a fraction raised to an exponent. So if I'm going to plug in 0, that means this is going to be 1/4 to the 0 power, and you should have learned in Algebra 1a that anything to the 0 power is 1. Okay, when I plug in 1, that's 1/4 to the first power, so that's just 1/4. If I plug in 2, it's 1/4 to the second power, which is 1/16. If I plug in 3, you can just see what they did here. They put some numbers as inputs, and then they figured out what that equaled when they plugged it in. So notice that this is a decreasing or decaying function. The values of the input column of the table are decreasing, or the output column is decreasing. So we started with 1, then 1/4, then 1/16, then 1/64. These are getting smaller and smaller and smaller. And that's what we would expect, right? Because this number, our growth factor, is between 0 and 1, which we know means decay. Okay, so if you don't have an exponential function rule and you just have an input-output table, you can still find the growth factor. So if we just have this, pretend they didn't tell us what it equals yet, they just gave us an input-output table. We can still figure out the growth factor. As long as you know that it is an exponential function, you can find the growth factor. Divide any of the f of x values, the output values, by the previous term. So we're just going to divide to see what's going on here. So for example, 27 divided by 9 is 3. Okay, 9 divided by 3 is 3. 3 divided by 1 is 3. 1 divided by 3 is 1/3. So the growth factor here was 3. So here they wrote that growth factor is 3. So we could write the exponential function if we wanted to, now that we know that the growth factor is 3. So here's a video. Sometimes they just build these right in, and you can watch this video and it talks more about what we just talked about. And then they give you some step-by-step examples. So this is what I think you should go in and do now that you've watched this video, and see how you do. And then we can talk some more. So find the growth factor. Okay, so why don't you try to do these step-by-step examples and let me know if you have any questions after that, and I'm happy to hop back on and help.